Awesome. Get started here. Well, hello everyone. Well, thank you first and foremost, thank you for having me present on this topic of AI's transformative role in manufacturing. And I'll start off with a quick introduction of myself. My name's Taj. I currently am residing in Ontario, Canada. I work at McMaster University as the manager managing the intellectual property at the university, which is a heavily research-intensive university. I manage intellectual property files in regards to mobile application software and artificial intelligence. I own a side consulting business in AI and a 3D printing company as well. I come from the United States. I grew up in the United States. I have experience in the United States military and the U.S. Army as an engineer. I studied aerospace engineering for a year before dropping out and joining the U.S. military and serving my country and getting out and studying geology and astronomy, where I conducted NASA-funded research in data analysis, where I had the great privilege of studying the star system behind me in my background, actually, the Orion trapezium star cluster. And that was pretty nerdy work, and I loved it, and kind of got me involved in space and just everything that's nerdy. So without further ado, I think I'll kick off this presentation. So today we're going to be discussing the current landscape in manufacturing, revolutionizing it with AI, and how it's been revolutionized with AI. It's not necessarily anything new in the scope of manufacturing, but how it's continuing to grow with AI, as also it's continuing to grow and evolve with specific 3D printing technologies as well. I'm going to discuss AI in design and prototyping, how AI is enhancing manufacturing's operational efficiencies, AI and how it's going to be driving supply chain optimization, as well as AI and sustainability. And we'll briefly go over some future trends and innovations in that sector as well, and we'll conclude our presentation. So as many may or may not know, the current landscape in manufacturing, we currently have traditional techniques such as injection molding, metal casting, and assembly line production, which was revolutionized by Henry Ford, as many may know. And the assembly line production really sped up manufacturing in general, and it really standardized a lot of these processes that we still see today. But there's still a lot of challenges with this type of with the type of traditional manufacturing we have today, such as high waste. We have high costs as well, and we actually have a significant problem with over manufacturing. We tend to see a lot of products that end up going to waste, and we overproduce a lot of product in our current society, and which can be costly not just to the manufacturers but to consumers as well. And early AI's integrations, we see a lot of AI being integrated into some of these into some of these manufacturing processes in the space of robotics. We're automating a lot of processes in that space as well. Let's see, we're also, moving on to revolutionizing with AI and SLS 3D printing. So what SLS 3D printing is selective laser sintering. And what that means is we literally have a 3D printing system. This is current technology. It's not anything necessarily new. It's currently being used in aerospace and automotive parts as well. So SLS printing, actually how it works is a high-powered laser and a powdered material such as nylon 12, polycarbonate, titanium. We can have many different metals and plastics and even glass. So what this printing process does is uses a laser to melt these pellets on a bed and mold them into solid objects. It's kind of the stuff out of sci-fi almost, it feels like, but it's quite real, and it's being used today. There are a lot of manufacturers using this to this day to create aircraft parts and to rapidly produce prototypes and things of that nature. There's a lot of there's a lot less waste that's produced from this manufacturing process itself. A A lot of the powder can be reused, so you're only using the laser to produce the material itself, and the powder is then recycled and used back into the system to produce other materials as well. One of the other benefits is that in this 3D printing bed space, you can actually stack as many different objects as possible. And what I mean by that is if you have a small object and you're printing it on a large size printer and need to produce a lot of them, you could actually stack each of these items on top of each other in this build space, so to speak, in 3 dimensions. So on an X, Y, Z axis, you can stack multiple objects and optimize for as much space as possible. Moving on, sorry. So this is actually AI in design and prototyping. So this is actually a photo of a rocket nozzle that was designed entirely by AI. And I'm going to go a little bit into this briefly. So this is a hyperganic EOS rocket nozzle, and it was designed by a computer-assisted drawing algorithm that uses what's called a Titan core processor. So it was designed in minutes, and it was 3D printed using SLS 3D printing in mere days. And what's interesting about this specific design is that it's beyond the capability of human imagination. So what this actually used is, and as many may know here today, is that AI is really built upon foundational data. So it's foundational data models that it built off of. And the more data that you get into a system, the smarter this AI is going to become, the more trained it is going to be on this data. So this specific foundational model was trained on aerospace methodologies and rocket equations and historical data from this aerospace company. And over time, as the data became more fine-tuned and as the AI became more fine-tuned, it was able to produce a product that is currently being tested. So we don't even know necessarily if it is as efficient, if it is more efficient, if it's practical even, but what we are doing is testing these current technologies and testing these products that we're creating in mere days. And it's really fast-tracking the design process from imagination to 3D product very, very quickly. So we're able to test these products in our marketplace. We don't have to spend months in a product cycle to really get our ideas together, sit down at a table, come up with an idea on a whiteboard, and now we're actually engineering it in a CAD design or a CAD program, and then 3D printing it and then testing it. Now we're having AI kind of completely fast track that entire pipeline or process of product to a product to market or product to testing it. So it's pretty interesting. And the other thing that even to bring up is if this product doesn't work, we can go back and in this feedback loop and tell the system, hey, these were the problems that we had with this specific item or this specific product. Please correct for this specific errors in these areas, right? And it'll fine tune itself even further and become only smarter after that. So enhancing operational efficiencies. One of the things in this, so one of the great benefits of AI in manufacturing is that this is also being currently used today is predictive maintenance. So we're actually able to use AI programs that can monitor our smart devices, all the tools and all the functionalities of equipment that we have on our factory floor can be connected in a hub, so to speak, a one-stop shop where everything's connected and monitored, and we can actually observe the life cycle of these parts, and we can replace them before they even become incapable of being used again. We can swap them out, swap out the parts. Furthermore, we can actually create systems where a dashboard or a system or a company's or manufacturer's system will be able to actually order the parts before they even go bad or before they even are not optimal for use. So this type of predictive maintenance is very powerful. And who knows, by then we'll have actual androids replacing the parts on the factory floor and not humans. I mean, we're getting pretty close to that. I'm sure many have seen Figure One and Tesla's Optimus Prime robot. And there's human-like robots that are actually being used or they're being tested currently that are going to be in the marketplace very soon. And robotics technology has been around for quite some time, and many may not know Boston Dynamics, which came out of MIT and developed like the robot dog. And it's been a long life cycle, and I think it's just becoming more mainstream today. And we're starting to see a lot of those products and a lot of that research and development come to life today. And it's shocking to a lot of people, but it's been around for quite some time. And it's really, we're seeing a lot of innovation come to life in a very short period of time. So like I said, so some of the benefits of AI-driven maintenance systems is cost efficiency. So we don't have to have any downtime on machines. Machines can keep continually producing and hopefully not overproducing, right? And we're producing just in the optimal range of what we need to produce. Like I said, extended equipment life. And one other very important factor here is improved safety. If we're not having to go and replace parts on the line or on a supply line, we're not putting humans at risk. So statistically, we're going to see a reduction in workplace incidents just based on the fact that we're not going to have to replace the parts as often. So AI applications in inventory management and logistics. One interesting concept here is that we have everything connected in the sense that everything on the floor is connected to the grid as a factory, and we're able to actually monitor and predict. There's another interesting thing here is to remember that AI isn't just some entity that can just do things. It's a predictive machine. It's creating predictions, and based on those predictions, it's providing those results on the most statistically likely outcome. And it's very similar to how humans also operate in that sense too. We're predictive machines. We just do it on a very, very low voltage. And AI does it on it requires a lot more compute to do it, but it still does it regardless. Excuse me. So what I mean by this is this one system could actually predict when supply and demand may actually go up and down. So we could actually create algorithms where we're determining peak and low peak energy efficiencies and when to operate at the most efficient time, right? And time is the most important thing here. So we could actually have this, we could completely solve the problem of over manufacturing or under manufacturing. We could just manufacture it at the most optimal rate for just based on supply and demand rates over time. So, and even quantify that even further, you could think about seasons too. So specific products are only made during a specific season or holiday seasons as well. So we could time it perfectly where we're producing these products at the most optimal time based on predictions. And like I said, tech integrations around IoT, so Internet of Things. Imagine a system where all the smart homes that we have smart homes and we have smart plumbing systems. We have smart devices that are connected where we're able to predict when specific parts, your filters need to be changed. Instead of having to go order it, it's just produced by a local factory and it's just mailed to you by a drone. And it shows up on your doorstep. Or you have an Android that's your companion Android in your house that's replacing it for you. All these things are within the realm of possibility and could be coming to us very shortly. So some of these statistics here I've references as well linked in the presentation, but so implementation of these predictive maintenance strategies could actually see reductions in unplanned downtime by 20 to 40%. That's absolutely phenomenal. And we could see a decrease in total cost of ownership by about 10%. So what this allows for is the bottom line, we could see cost savings across the board, which hopefully translates to consumers as well. So we could see a reduction in cost for products. That's ideally what we want to see too, and not necessarily an increase in profit margins, but that's of course what we're going to see too. So the whole point here is if we see a cost reduction in producing products and producing factories and manufacturing facilities, we'll see a reduction in cost across the entire board. Sustainability and AI. So I brought this up briefly, but one of the great things here is with SLS, especially with SLS 3D printing and other technologies in manufacturing, we're going to see reductions in material waste. We're going to see energy efficiencies. Like I mentioned, those AI algorithms are going to predict when to best produce something based on electricity's uh, peak time and low peak time, and electrical production rates in the energy sector. Um, we could even go further and look at geopolitical events too. So if we have an algorithm that's monitoring world events and predicting, okay, wait, hold on, maybe oil and gas or specific energy sectors are going to be affected by this. So we should kind of adjust for that, because, in the next month or so, we could see ramifications from these events. That could be huge. This is all part of predictive analysis and predictions that we can create within these manufacturing ecosystems. And the use of recyclable materials, of course, is huge. We all hear about recycling, and a lot of the stuff just ends up in the same place. And we kind of, and this is true across many different industries as well, where we recycle these items and they just end up all in the same place in terms of like a waste dump or something like that, because the cost of recycling is so high. What AI in this sense could actually optimize and determine the actual it could actually reduce the cost of recycling these items. For example, like I brought up the SLS 3D printing, that powder doesn't go to waste. The metal powders, the nylon 12 powders, they get reused, they get recycled and reused back into the system to produce more product. So that could be a huge benefit there for a lot of different products. And like I said, we're going to see cost reductions in those products as well that are produced by them. So some of the future trends, excuse me, and innovations here, AI manufacturing data as an asset. So what I mean by that, I think I've briefly touched this. The fundamental aspect of AI is data. Excuse me. If you don't have clean data, you won't have a clean AI. You won't have an AI that's producing effective results, right? It needs to be fine-tuned more. It's going to take more time to train it to become better. So what we're going to see is a lot of these big manufacturers, we have ABB producing robotic arms, we have Siemens, we have Rockwell, we have all these large companies that help produce these parts for manufacturers. We're going to see a lot of them start to culminate their own data sets based on their own customers. And what that's going to mean is that those data sets, those foundational data models are going to be they're going to be essentially they're for a lot of different other manufacturers. So if I'm another manufacturer, competing manufacturer, and I don't have enough data, I don't have enough data assets to really build an AI or an effective AI model, I might want to license out another company's data assets to build my own AI. And you're going to see this huge market. And we're already seeing this too. We're seeing a lot of databases being licensed out in this manner to be used and help train AIs as well. And we're going to see increased productivity. I think that's a given. And what productivity means is that we're going to see bigger bang for our buck, so to speak. And it's going to be much more resourceful in that sense. And one of the other cool concepts I think I thought of too is automated smart mini factories. And instead of having one large giant Amazon warehouse located in every city, we're going to have these small mini factories that can really produce whenever they need to produce and not necessarily producing all the time. And imagine a neighborhood that has an onboard SLS 3D printing system that could quite literally produce everything that you need for that community. This could be huge in that sense. So we're talking small to medium production instead of large scale productions. Like I said, over manufacturing, over producing. We don't want to do that because a lot of it goes to waste. And a lot of these companies, they write it off because if the waste, it's still within their parameters of producing profit. So to them, it's just a number. However, these products that are just put to waste, they have to go somewhere, and so having these small little mini factories could actually help reduce a lot of that waste, and it could be highly sustainable in that sense. And they're much easier to maintain when they're smaller, right? Another great feature here is automated construction. What I mean by that is this has been thought of too, in the sense that when you're building a building, currently there's a lot of people involved, and there is some level of automation being put forth. I mean, you're seeing a lot of automated self-driving high-X machines and bulldozers and things of that nature. But furthermore, you could have robotic arm systems that could assemble entire buildings. But how do you know if it's being assembled properly? So a lot of the visual machine learning systems that are being produced right there, we're going to be using similar systems to self-driving cars, where these cameras and LiDAR systems are actually visually analyzing the building process of an actual building that's being put together properly, right? And over time, you'll have these algorithms that are trained on what assembly of a specific building or a specific house would look like in the most optimal conditions. Once you've established a baseline for this construction, you can then create visual algorithms to analyze construction as it's happening in real time. And the AI will be able to predict, okay, this specific structure over here has a 60% failure rate potentially. So please go check it out. Please check it out. Make sure it's not, it's being put together properly. So this type of visual aspect is going to be very important too. One of the other things I've seen is smart glasses. So for workers or even robots that go and check welds, they can check welds on buildings, they can check welds on automotive parts and determine if the weld is appropriate or a successful weld based on prediction, right? So if it has a robust data set or foundational database of what successful welds are or successful assemblies are, it can determine that if there's a high probability of failure. We could even think about looking at bridge construction. We're seeing a lot of bridge collapses today. Imagine having like a visual system that could look at that just keeps its camera on the bridge and it's able to determine structural integrity of these systems. There's a lot of automation, a lot of possibility here in that sense as well. So another great thing, I love to talk about space. So I kind of had to include something on space here. And especially in the realms of manufacturing, we're all talking about we're getting to the point where we're talking about, there's funding being thrown into lunar-based developments and Mars explorations. We're not necessarily talking about just sending probes now. We're talking about establishing actual habitats on the moon and for resource utilization on the moon as well as asteroids. So that we're going to need manufacturing to be able to produce items like while you're there. We can't constantly send things into space because it's very expensive. So one of the cool features in research and development areas has been 3D printers in space and SLS printing in space as well, or in situ resource utilization. What that means is utilizing the resources around you to produce products. Blue Origin, which is off of Amazon, they've just successfully created solar panels out of regolith, and regolith is lunar rock. So being able to produce solar panels out of the resources around you is a very powerful thing because you can then now produce energy on the moon with the resources that are available around you. Another thing, spacecraft repair. Having an SLS printer or a 3D printing system on your spacecraft and there's parts that go haywire or need to be maintained, you can have an AI that's monitoring the spacecraft and it's able to produce these parts to replace the spacecraft. It's all there. I mean, we're talking about like things that we thought 20, 30 years ago were the realm of science fiction or were coming out of Star Trek. I mean, this is the stuff that we thought about. And I think a very famous quote, I think I'll get to that here on this slide. Yes. Imagination is more important than knowledge. Knowledge is limited and imagination encircles the world. This is one of my favorite quotes by Albert Einstein. And it really encompasses, I think, the power of humanity in the sense that everything that we've thought of, like all the things that we're seeing today, we thought were science fiction, or we imagined them at some point. And we put them in film, we put them in different art, we put them in different aspects of our culture, and now they're coming to reality. It kind of showcases the power of human imagination, and that knowledge is really just limited in that sense. So the power, the future is really just bound by just limitless imagination. So if we continue to imagine cool things and things that can really solve all our problems. I think we'll get to a point where we're going to see a lot of interesting, we're living in very interesting times right now. I mean, just seeing the culmination of these powerful AI algorithms and how they're going to revolutionize different aspects of our lives and hopefully make lives better for everyone, especially in the space for manufacturing. So with that, I'll end my presentation and I want to thank everyone.
Thank you so much. We have
Thank you.
time for a couple of questions.
Yes, I do.
Would you mind speaking loudly?
Could you imagine an AI application which deals with all that space debris flying around in the orbit?
Yeah. Did you get the question?
I think all I heard was the space debris and AI, so I can glean it. I don't know if you could repeat.
Could you imagine an AI that will deal with all of the space debris?
Yeah. Okay, great. Okay, that's what I thought it was. All right. So yeah, I can imagine that. I think it's really interesting. Well, right now we're tracking a lot of the space debris, right? So, but we can only track so much, and we can only see so much that's up there. But based on what we know is up there, absolutely, we could create an AI that is not just monitoring the debris, but also predicting where it goes. And I think we currently have systems that do that. We can predict where an object is going to go, and effectively create paths for satellites being put up in space and specific rockets to maneuver around it. I mean, I'm sure we've all heard or may have heard of recent stories of near misses, near collisions of space debris and rocket launches. And I think that's why communication between different space agencies is very important. But like you said, an AI that could actually just monitor it in real time, 24/7, and not have humans necessarily. We'll still have humans there at the helm, but having a system that could provide alerts like, okay, wait, and this technology probably already exists too, but making it more robust, making it far more fine-tuned. And one of the cool things I have seen, and I think humanity has seen, a lot of the research and development, a lot of the products that we're seeing today have been around for a long time. They've been produced through research and development funding dropped into space development, space exploration, medical fields, things of that nature. And they just trickle down slowly into the public sector, into private sector. And also military defense spending as well. A lot of the technologies that come out that we're seeing today in private sector all derive from space R&D and defense as well.
Okay, thank you so much. Where can people get in touch with you?
Yeah, so I have a website, tempistinnovation.com. If there's any questions or if you'd like me to do any more presentations on anything from quantum mechanics to space stuff to AI, I'd be happy to answer questions and help out where I can. So feel free to reach out to me at tempistinnovation.com. I'm also on LinkedIn, Taj Sarin on LinkedIn. Feel free to reach out, and I really appreciate everyone's time here, and thanks for coming.